Welcome, folks. Today, we're discussing the use of large language models, or LLMs, in semantic communication. It's a fascinating area at the intersection of AI, information theory, and next-gen communication networks.
Sounds interesting. So, what exactly is semantic communication? How does it differ from what we're used to?
That's a great question. Traditional communication focuses on transmitting symbols accurately, making sure the exact bit sequence gets from sender to receiver. Semantic communication, on the other hand, cares more about transmitting meaning. It's not just about getting the bits right, but about ensuring the receiver understands the intended information.
I see. So it's less about perfect data transfer and more about understanding. Where do LLMs come into play here?
LLMs are trained on massive amounts of text, allowing them to understand context, relationships, and general world knowledge. This makes them perfect for interpreting, compressing, and reconstructing information based on meaning rather than exact wording. They can act as semantic encoders and decoders.
Got it. So how would an LLM-based semantic communication system actually work?
In a semantic communication pipeline, the sender uses an LLM as a semantic encoder. This encoder extracts the essential meaning from the message, gets rid of any redundant information, and turns the message into a compact semantic representation. This compressed representation is then sent through a communication channel.
And what happens on the receiving end?
At the receiver, another LLM, or a compatible semantic decoder, reconstructs the intended message from the received semantic representation. Even if the signal is altered by channel noise, the decoder can often recover the intended meaning by using contextual reasoning and prior knowledge.
That sounds like it could offer some real advantages. What are the main benefits of using this approach?
There are several key advantages. First, it can significantly reduce bandwidth requirements because only the meaningful information is transmitted. Second, it improves robustness to channel noise since reconstruction relies on semantic inference. And third, it enables adaptive communication where the system can tailor the transmitted information based on context or requirement.
Can you give me a concrete example of how this might work in practice?
Sure. Imagine a sensor network reporting environmental conditions. Instead of sending raw numerical data constantly, a semantic system with an LLM encoder could send a concise message like, "Temperature rising rapidly beyond safe threshold." The receiver understands the situation without needing every single data point.
That makes sense. It's like sending a summary instead of all the raw data. But are there any downsides or challenges to this approach?
Absolutely. One major challenge is defining quantitative metrics for semantic accuracy. Unlike bit error rate, semantic correctness is subjective and depends on the context. Also, LLMs require significant processing power, which can limit their use in edge devices. Finally, security and reliability are concerns, since semantic reconstruction relies on probabilistic inference and could introduce errors or unintended interpretations.
So, there's still work to be done in terms of validation and ensuring accuracy. What's the future looking like for LLM-based semantic communication?
Ongoing research is exploring how semantic communication frameworks can be standardized and integrated into next-generation wireless systems, like 6G. The goal is to measure communication efficiency not just in bits per second, but also in meaning per second, reflecting how effectively information is conveyed relative to resource usage.
Meaning per second, that's an interesting concept. It sounds like LLM-driven semantic communication has the potential to really transform how we think about communication systems.
Exactly. By understanding and generating language at the level of meaning, LLMs can enable communication systems that are more efficient, robust, and context-aware. As research continues, it's expected to play a central role in future intelligent networks, autonomous systems, and human-machine interaction frameworks. Well, that wraps up our discussion on LLMs and semantic communication. Thanks for tuning in, folks. Goodbye.